So, quick background and introduction to who I am. I am the field CTO at Span. Span is a product that connects to the places that your engineering team does work. So, we integrate with your source control like GitHub and GitLab, your ticketing, the Gen AI tools that your engineers are using. And with all of that insight, we help you understand your software development lifecycle, what's going well, where there are bottlenecks. We quantify and instrument overall development productivity. But before that, I was an engineering leader. So I was the CTO at Lattice, which is a B2B HR product. Before that, I was the director of engineering at Dropbox, where I spent 8 years really growing my career and stepping into leadership. And then I started my career at Apple as a software engineer. I was working on the Xcode developer tooling products, and learned, the importance of crafting delightful, beautiful UI and UX. And that has been a part of my kind of product orientation in my engineering leadership ever since. So I'm sure we have all seen the headlines about the impact of AI on development productivity. Whether it's claims of 20% or 40%, or even as extreme as going 5 times or 10 times faster, folks claiming that projects that used to take months now can take a single day. There's a lot of information and noise out there, and some of it's real, some of it's not as real, and it's hard to kind of make sense of all of this and how it's changing everything in the development world. Yet at the same time, as we have been spending time with engineering leaders, both in consumer companies and in B2B companies, we've been hearing anecdotes such as this one. Yeah, we've been spending all this money on AI tools, but the thing we really care about is how many experiments we ship per month. And it's not really noticeably changing. Or another engineering leader at a public B2B company that we were speaking with said in December, hey, we're doing annual performance review season, and we're looking at like the net impact that we were able to deliver in 2025 relative to the net impact we were able to deliver in 2024. And it doesn't feel remarkably different despite all of this kind of AI utilization. And so it's very hard to make sense of what's truly happening with these headlines and then with these anecdotes. And it feels like everybody has a slightly different opinion and slightly different take on what's happening with AI and software development. And I think part of the challenge that we're experiencing is that the stuff that is easy to measure isn't necessarily telling us the whole story. So a lot of the effort to quantify engineering productivity has dialed in on metrics like these: lines of code, number of commits, number of pull requests, maybe story points. And these proxy metrics just don't correlate with end user impact. More lines of code does not mean that you're more productive, right? In fact, it may be encouraging unnecessary complexity and more verbosity in the code that you're authoring. And indeed, we're hearing stories of these AI agents and AI tools yielding larger volumes of code and more complex code that now you have to support and manage and maintain. Similarly, with commits and PRs, that can encourage your team to make artificially small pull requests, which actually, to an extent, that's good. Like smaller PRs are easier to code review, easier to roll back. So there's a benefit to smaller PRs, but it has diminishing returns, right? There's a point at which it's not a great North Star metric to drive because you're no longer getting benefit from making changes smaller. And then story points, they're subjective. They're not necessarily comparable across teams. It can encourage your team to inflate their estimates. We've also heard stories where the same scope of work, pre-AI and post-AI, is yielding different story point estimates. So maybe something that used to take 10 story points, now the team knows that they can do it faster. They're only estimating it at 2 story points. So if you're looking at story points over time, you won't actually see an uplift from pre-AI to post-AI. So all of these kind of have their own challenges. They're very easy to measure, and that's why we like to index on them, but they don't tell the whole story. So the other thing that we're seeing people do is use surveys. So if you can't quantify stuff, let's just ask engineers, is this making you more productive? How much time are you saving? And the challenge with surveys is that engineers are really bad at self-estimating their own productivity. So there's this popular study that came out in July of last year, the METR study, and it asked folks, it was an open source project where folks were allowed or disallowed from using AI tools randomly on tasks that they were assigned. And then they were asked after the completion of the task whether AI had helped speed them up. And so the folks who had access to the AI tools believed that AI had sped them up by 20% because they felt more productive working with the AI tools. But in practice, looking at the task duration, accounting for complexity, it actually took them 20% longer. And so there's this lack of correlation between actual productivity and self-reported productivity that makes it hard to rely on surveys for this either. So if you'll allow me to wax philosophical for a minute on how I think about engineering productivity at the highest level, our job as software engineering leaders is to produce value for our customers, right? We need to produce business value. We have tools at our disposal to do that, which is our team and our technology. So the input is our headcount, our labor. It is the tools that we use, our AI tool spend, token utilization, compute, and so forth. And then we have this process that we run with our team, Scrum, Agile, what have you, to ultimately yield capabilities and features that our customers use that hopefully are high quality and delight them and deliver satisfaction. So their lives are easier, they save time. And so the input is dollars, it's how much we spend. And the output is dollars, it's how much we collect in terms of revenue thanks to the value that we're able to build. And so a lot of how folks have thought about engineering productivity has focused on the middle, this software development lifecycle box. And it's useful. I'm not saying Dora is not useful. It is useful. It helps instrument the process. It helps shed light on bottlenecks in your team. You can look at PR cycle time to identify issues in your code review process. You can look at lead time for changes to identify issues in your deployment infrastructure. These are useful metrics, but they don't tell the whole story. In order to look at the whole story, we really need to understand how much are we spending on any given initiative. So how much time is the team spending on it? How many tokens are we spending producing it? And then we also need to look at the output. Like, was the delivery of that software artifact impactful? Are customers using it? Are they happy using it? Is it high quality? What's the defect rate? Is it stable or is it buggy? Does it have high performance characteristics? And so I think as we try to broaden our aperture to understand the impact of AI on software development, we need to broaden the set of metrics that we're looking at as well and go beyond these activity metrics into the inputs and outputs of the development process. So I really liked this visual from the Pragmatic Engineer newsletter. I don't know if folks read that newsletter. It's a really great newsletter about engineering and engineering leadership, and there's been a lot of articles lately about the impact of AI. And there was this great visual in one of the recent articles this past week. Wait, writing code fast was not the bottleneck, never has been. And I think we're seeing this especially now as Claude Code and Opus 4.5 and Cursor and so forth are making it cheaper and cheaper to take an idea and generate the code. The bottleneck is increasingly not the code authorship. It's all the stuff at the periphery of generating code. And so Span works with a number of customers, both kind of private later stage technology companies as well as public companies. And we have some benchmark data from October 2024 to October 2025, which we're going to continue to refresh because everything is changing so quickly. And what we're seeing is that throughput is indeed higher. Like the customers that we work with are shipping more PRs as they adopt AI. And so that velocity story is kind of true. But what we're also seeing is that as more pull requests and more code is being generated, there is a heightened rate of rework, meaning that pull requests are going through more rounds of feedback and iteration, and there's more code churn after code is being deployed. We're also seeing an increase in the number of review cycles. So if you think about like the round trips, the number of back and forths that a given change has to go through in code review, the byproduct of AI adoption is more of this iteration and back and forth. And so you're seeing a compression in one part of the cycle, which is the code generation part, but an elongation in other parts of the cycle, including the code review part. So our point of view is that this overemphasis on velocity is kind of missing the bigger picture, which is that AI adoption requires us to rethink the entire software development lifecycle. It's not just how engineers generate code, it's how code is reviewed, how quality is ensured as code is deployed, and ultimately how products are distributed and adopted by end users, because we can produce 100 different features, but if customers can't discover those features, have them be well integrated into their workflows, have them solve real problems, then it's kind of like a tree falling in the forest with no one around to hear it, right? And so thinking holistically about how this software has end impact with our customers is really the big picture story. Just going to take a quick sip of water. So as we've been working with our customers and instrumenting these different dynamics inside of the software development lifecycle, we're seeing that there's really a journey, like an AI transformation journey that organizations are going on. And there's a few different chapters or stages to that journey, if you will. I think in 2025, the big story was all about adoption. It was like rolling these tools out, getting engineers excited to use them, overcoming friction. There was a lot of resistance. I think people tried some early models in 2023 or 2024 and maybe wrote off AI as, insufficiently powerful or having too many challenges to really adopt. Um, but there's been various strategies here to try and promote adoption and get people on board. Now, what we're seeing is a lot of those companies that pushed heavily for adoption are experiencing some strain as the AI code generation is scaling faster than their process can. And so code review and quality guardrails and things around the periphery of code generation are starting to break. We are seeing companies mature through that strain, through the thoughtful deployment of guardrails and quality investments, which we can talk about some examples of later in the presentation, and sort of grow into proficient utilization of these AI tools. But now their spend is starting to become high. And as I look at the future and I see, many of these model providers, these leading AI tool companies, they're providing very, very subsidized token costs right now, right? Sort of traditional venture funded model. Let's get people hooked. Let's subsidize the costs. But I think as we look ahead, we can expect that these token costs are going to rise. And much like the migration to the cloud, we're going to see kind of token spend optimization become a thing, much like we needed to optimize our cloud spend after we started migrating our workloads to the cloud. And so I think the final stage of this chapter is going to look like true mastery, where there's high velocity, there's high quality, and there's very cost efficient AI usage after those costs have been dialed. So here's kind of some directional signals that we're looking at to identify what stage a company is in with this journey. So AI adoption starting low, growing to a majority of the organization, and then possibly even everybody, 100% of the organization, 100% of changes incorporating AI. PR cycle time starting at some baseline with the old way of doing things, slowing down as this AI code generation problem emerges and people are not having the review capacity to keep up, but then ultimately working through those to get back to a baseline or possibly even faster. Quality with some level of degradation as some level of AI slop is making its way into the code base and into production, but then ultimately tuning and correcting those issues to a proficient and high quality usage of these tools. And then ultimately cost as a fourth factor, looking at how much you're spending to bring an initiative to life. Token spend is rising. It probably will continue to grow as these model companies need to raise prices, but then eventually being optimized. So given that, so many companies right now seem to be in either the adoption chapter or the strain chapter, I figured I'd also just talk through some examples and some strategies that we're seeing that are working well for helping companies move from one stage to the next. And so we can start with adoption and talk about some of the strategies we've seen to promote adoption and learning. Top-down mandates. For example, we just heard a late stage private unicorn tell us that they have issued a mandate to their org that every single code change needs to use Claude Code. So it needs to be a reflective reach for Claude Code for the very first, no writing code by hand to start, always start by trying to use Claude Code first. It could be a top-down mandate in the form of AI fluency is now an expectation of your role, and we're going to evaluate your AI usage during performance review season and so forth. Another tactic we've seen is like embedding leadership. So, taking a senior leader and not just kind of telling folks that they need to use AI, but leading from the front, showing what it means to use AI, embedding with a team, partnering, and, kind of being that hands-on leader. Another is making sure that folks have carved out time to learn. When engineers feel like their incentive is to deliver a project on time with a high degree of dependability, taking a detour to try something new can be scary because it's like, well, I'll be penalized if I don't deliver this thing on time. I'll do the thing that I know how to do. And so intentionally creating outlets, whether that be like a hackathon or a hack week or elongating a project timeline so that there's carved out space to take an AI first approach. We've seen teams doing that. Internal communities, Slack channels, prompt Fridays, lunch and learns, folks showcasing and demoing what kind of AI tools and AI tactics they're using to good success. And then gamification and recognition, tracking adoption, showing dashboards by team, highlighting folks who are doing really cool stuff with AI, putting them up at all hands and celebrating them to create incentive in the organization. So then once folks are really heavily adopting, there's the strain, now it's like, oh, we're generating all this AI code, but like code review is a new problem, quality guardrails are a new problem. What are we seeing here? um, Investment in agents.md, investment in upfront expectations of standards, linters, things like that. So repeated kinds of feedback that need to be provided to agent generated code. How do we take those patterns and push them left in the development process, codify those expectations up front in markdown files that are specifying what good looks like to these agentic tools? Instrumenting code review workflows so that you can understand those patterns and you can understand whether code review is slowing down or there's bottlenecks on certain reviewers. One private fintech that we spoke with said that they had a really strong set of release guardrails. And so they actually created a system that would assess the risk of a given change based on where in the code base it was being introduced. And if it was a low risk change in a low risk part of the code base, they would auto merge without human review. So that was to alleviate some human review burden. Test cases, making sure that you've got really robust test case quality so that you can care slightly less about the quality of the code as long as it can pass all of the tests. Review bots are becoming a bigger thing. A lot of them don't work quite right off the shelf, but as you tune them and refine them and use common sources of feedback from the code review process, you can deploy those review bots as a good first pass, take the false negatives, tune them to be better. Workload balancing across reviewers, identifying certain parts of the code base where maybe there is a low bus factor and there's a certain set of engineers that you're over reliant on for code review, helping alleviate those bottlenecks. And then a big one is, especially for a lot of more junior ICs, making sure that the expectations are clear around what constitutes code that is ready for review, right? So it's not just get shit done. It's not just close the ticket out. It's like when a code review goes up for review, I expect that there should be very low back and forth. You should have already pre-validated that the functionality works well. You should have already taken a first pass on reviewing it yourself, et cetera, and just making sure that those expectations are really clear so that you are rewarding quality and setting expectations around quality, not just velocity. So a couple closing thoughts, right? The real goal with all of this stuff is not more AI. I think a lot of the headlines and a lot of the conversation in 2025 has been indexed on promoting adoption. We need to get 100% of engineers using AI. We need more AI in our usage. And I think that is a means to an end. It's a good input, but it's really what we're chasing is better outcomes. We want to have more velocity, higher quality, an understanding of cost efficiency and how much we're spending, and make sure that the ROI of these tools is clear to executives and to boards. And AI is definitely here to stay. I'm sure some of us played around with Opus 4 or 5 over the holidays and are just seeing the power and the potential and how crazy this stuff is getting. It's agentic development is here. It's going to reshape how we do software development. But there will be new bottlenecks and there will be new challenges as you go through this journey. And winning teams will be the ones who instrument and optimize and understand where those new bottlenecks are happening. Some practical guidance is to establish your baselines now, understand how you're doing in terms of delivery, measure across all dimensions, not just pull requests and velocity and DORA, but multiple other dimensions of the delivery spectrum, and expect that you're going to run into stage two and some level of strain and some new challenges are going to emerge. Prepare for it, and make sure that you're investing not just in adoption, but in some of the guardrails as well. Couple takeaways for leaders here, kind of three critical mindset shifts. One, stop optimizing for output, code, pull requests, lines of code. They're all means to an end. Start optimizing for outcomes for your customers. Two, stop treating AI as a feature, as like a new tool, and we'll just get licenses for people and make sure they're using it and we're good to go. It's really a transformation. I think the whole software development lifecycle is going to need to change, and you'll have to look at your process from how, you know, product specifications are defined all the way through to how products are distributed and adopted by your customers, and thinking through that full journey from soup to nuts. And the third is let's stop celebrating velocity as an industry. It's clear velocity is up. We can just call that done. But let's start measuring all of the other things too and make sure that net impact is actually improving and that it goes beyond just code velocity. So that's what I got. Thank you so much for listening. I didn't put my email here, but it's steven@span.app. So happy to have folks get in touch after the call if I can be helpful. And I think at this point, we'll open it up for Q&A and discussion.